Assalamualaikum and a very good day, class. So we meet again in this week 3 video. We still under topic first order ordinary differential equation, but for today we'll cover here the solution of differential equation. And also we'll go later for the general and particular solution. And the last part is initial value problem and boundary value problem. The solution of differential equation is referred to the unknown function y and its independent variable x on the interval I, in which this function yx satisfies the differential equation identically for all x in I. So to make sure you understand this definition, let's now we go to the example of this part. So the first example here, let's say we have yx equal to c1 sine 3x plus c2 cos 3x. We want to check now for arbitrary constants c1 and c2, is it this equation yx is a solution for y double prime plus 9y equal to 0. This is a step how to solve it. So now class, to make sure you understand, let's we do it one by one. We have here y double prime plus 9y equal to 0, and we want to check whether this y equal to c1 sine 3x plus c2 cos 3x, is it this equation is a solution to this differential equation. So how to check? You see in this differential equation, you have a term y double prime and you also have a term y. Means that you need to substitute y double prime and y in this differential equation. And then if this right hand side equal to 0, means that it's fulfill this differential equation, so that this y is a solution for this differential equation. So let's start one by one here. Let's go one by one here. So let's go one by one here. First, we differentiate this y. We have here y prime equal to 3c1 cos 3x. You need to have knowledge how to differentiate this function. And then here, when we differentiate cos 3x, we'll got here negative 3 sine 3x. So we'll have negative 3 c2 sine 3x. And then we need next to differentiate this y prime. So we have y double prime, and then when we got this one, we can substitute in this equation. So y double prime equal to negative 9. Why we got here 9? Because 3 times 3. Negative because you differentiate cos x, you will got negative sine x. So negative 9 c1 sine 3x minus 9 c2 cos 3x. And the next step, number 3, we need to substitute y double prime and y in this differential equation. So we'll have here y double prime equal to this equation. So we'll have negative 9 c1 sine 3x minus 9 c2 cos 3x, and then plus 9, our y is this equation. So we substitute here 9y, you substitute with this part. We'll have here c1 sine 3x plus c2 cos 3x. So we'll have this one equal to negative 9 c1 sine 3x, and here we have plus 9 c1 sine 3x, so plus 9 c1 sine 3x and minus 9 c2 cos 3x, and then plus here 9 c2 cos 3x, and then you can see this one will become 0, and here you can cancel out, become 0, means that it is equal to 0. When this one equal to 0, means that you have shown this y double prime plus 9y equal to 0. So we can conclude here y equal to c1 sine 3x plus c2 cos 3x is a solution for y double prime plus 9y equal to 0. Now class, we go to the next example. You need to determine whether y equal to x squared minus 3 is a solution of y prime to the power of 3 plus y equal to 0. How to show this? You have to find here y prime, and then you need to substitute in this equation, and then you substitute y here. If you can show the right hand side equal to 0, means that this y equal to x squared minus 3 is a solution for this differential equation. So the first step here, we compute here y prime. Simple function, so you can directly find the derivative of this function. It is equal to 2x. And then we know that our y equal to x squared minus 3. So we need to substitute y prime and y in this differential equation. So for step number 2, we have here y prime, okay, y prime to the power of 3. So 2x to the power of 3 plus y. And y is given by x squared minus 3. When we solve this one, we got this part is ax to the power of 3 plus x squared minus 3, which is it is not equal to 0, means that we can conclude here y equal to x squared minus 3 is not a solution for y prime to the power of 3 plus y equal to 0. Next class, we go to this example. Is yx equal to 10 a solution of y double prime plus 2y prime plus y equal to 10? Here we have y equal to 10, means that when we differentiate this one 1, we got it is 0. We differentiate again twice, we got here equal to 0. For step number 2, we substitute y double prime, y prime, and y in this equation. So we will have here 0 plus 2 times 0 plus 10, which is when you solve this one, you got equal to 10. So this one equal to this answer, means that we can conclude here y equal to 10 is a solution for y double prime plus 2y prime plus y equal to 10. Now we go to types of the solution. In ODE, there are two types of the solution. The first one we call it as general, and the second one is particular. What does it mean by general solution of ODE? It's referred to a solution of differential equation which contains one or more arbitrary constants. Means that in this case, when the solution is said general, it has a constant. Contains a number of arbitrary constants equal to the order of the. If the order of ODE is 2, means that number of constant also 2. It is the set of all solution, means that this arbitrary constant can be any value. It cannot always be expressed by single formula. Okay, because actually, for example, if we have yx equal to 7x plus c, this c can be any value. You can substitute with 1, 2, 3, and so on. So it cannot always expressed by a single formula. And for this one, if you have yx equal to c1 exponential 2x plus c2 exponential negative 3x, we can say that c1 and c2 are constant for this case. And there are two constants here, means that the order of the differential equation that has this solution is. And then we go to the particular solution. When additional information is given so that constant may be calculated. If you have additional information, so you can calculate the constant. In that case, the solution is called particular solution. For example, if this c, we can compute it and we got actually 4 here. So this y equal to 7x plus 4, we call it as particular solution. And for the second one here, if c1, you can calculate, which is you got negative 1. And c2, you got equal to 6. And then so the solution of this yx, we can call it as a particular solution. Now class, we go to this example. You need to find the general solution of the following differential equation. Remember, general solution means that the solution it is in the form of having arbitrary constant. So how to solve this? To find general solution, we need to integrate both sides. Integrate of dy dx equal to integration of 2x. Means that in this case, you can write integration of dy equal to the integration of 2x dx. So when we solve this one, we will have here y equal to 2x squared divided by 2 plus c. Means that we will have here y equal to x squared plus c. When you have here arbitrary constants, means that this one we call it as our general solution. Then, if y0 equal to 3, the question asks you to find the particular solution of the differential equation. Means that when y0 equal to 3, you can substitute y0, which is equal to here. This is the value of x. Means that y0 equal to 0 square. The x here, you need to substitute with 0 plus c. Means that y0 equal to c, but based on the question, y0 equal to 3, so this c equal to 3. So our particular solution in this case, it is in the form of y equal to x squared plus 3, because based on previous calculation, we got here arbitrary constant equal to 3. So this is our general solution, and this one is our particular. Now class, we go to initial value problem and boundary value problem. A differential equation with subsidiary conditions on the unknown function and its derivative are all given at the same value of the independent variable. We call it as initial value problem. Means that if you have differential equation with initial value, so when we plot here at x naught, you know your y naught. So this one we call it, for example, y at x naught. For example, our x naught equal to 0. So y at x equal to 0. Let's say it is equal to 1. When this information is given at initial, we call it as initial value problem. But if the conditions are given at more than one value of the independent variable, the problem is a boundary value problem. It means that if I have, for example, this line, this one is x naught equal to 0, and then I have here, let's say x1, let's say equal to 1. So I know here y0 equal to 0, y1 for example equal to 2. It means that in this case you have two value at independent variable x, which is x0 0, y0 0, x1 1, y1 2. In this case, we have more than one value of the independent variable, so we call the problem as boundary value problem. If we see here the example, y double prime plus 2y prime equal to this one, and if you see here, you have y0 equal to 1, y prime 0 equal to 1. So you see here at one independent value, we can say that it is initial value problem. But for the second case, we have the same differential equation, but now we have condition at y0 and also at y1. That is here you have two independent variable. Means that in this case we call it as boundary value problem. So class, if you go to this example, which of the following functions are solution of the differential equation? How to solve this? Here we have y double prime plus 4y equal to 0, where we have y0 equal to 0, y prime 0 equal to 1. If you see this problem, this is ordinary differential equation, and here is a initial value problem because we have the condition at only one independent variable. How to solve this? Let's check for this a. A is given by y equal to sine 2x. If this function, a solution for this equation, means that this function, when you differentiate it twice, then you substitute in this y double prime and this y you substitute here, you will got equal to 0. Let's do that. So when we differentiate this one, we got here 2 cos 2x. When I differentiate it twice, I will got here negative 4 sine 2x. When I substitute y double prime and y in this equation, I will have here negative 4 sine 2x plus 4 multiplied by sine 2x, which is equal to, we can cancel out this, we got equal to 0. Means that this one is the solution for this equation. But we need to check here, is it y at x equal to 0 equal to 0? So now we check y 0, when here 0 means that this sine 2x, for this x you need to substitute with 0. It is equal to sine 2 times 0. Means that when we solve this one, it is actually sine 0, which is equal to 0. So it's fulfilled for the differential equation. It's fulfilled for the initial value problem y0. And then we need to check for the y prime 0. Y prime 0, it is equal to 2 cos 2. This one is referred to x. Means that 2 here times 0. When we solve this one, cos 0 you'll got equal to 1, which is 2 times 1, which is equal to 2. When we see here, this one is not fulfill y prime 0 equal to 1. Means that it is not equal to 1. So not fulfill this condition, we can say that y equal to sine 2x is not a solution for this differential equation. Now class, let's do for B. B we have y equal to x. When I differentiate this one, I got y prime equal to 1. And then y double prime equal to 0. When substitute in this differential equation, I will have here y double prime plus 4y, it is equal to this y double prime is 0. 0 plus 4 times y is x. So 4x, which is equal to 4x. You can see, based on this one, our y double prime plus 4y equal to 4x is not equal to the left hand side of this equation. To the right hand side of this equation means that not equal to the 0. So in this case, we can say that y equal to x is not a solution of this differential equation. Class, we go to C. C, we have y equal to 1 over 2 sine 2x. In this case, when I differentiate this one, I will got here 1 over 2 times 2 cos 2x. So equal to cos 2x. And then I differentiate it twice. I will have here, we need to differentiate this cos 2x. So I will have negative 2 sine 2x. When I substitute y double prime and y in this differential equation, I will have here negative 2 sine 2x plus 4 times 1 over 2 sine 2x. When I solve this one I can cancel out. I got 2, which is clearly it is equal to 0. So it's fulfill this differential equation. So for number 1, it's fulfill this differential equation. Now we check for y0, is it equal to 0? Y is given by this equation. So when x equal to 0, this x we need to substitute with 0, which is equal to 1 over 2 sine 2 times 0. So here sine 0 it is equal to 0, means that this one equal to 0. It's fulfill this initial condition. Now let's check for y prime 0. Y prime is given by this equation. So now when we substitute x here equal to 0, here this one equal to 0, y prime 0 equal to cos 2 times 0. That is cos 0, which is equal to 1. So you can see this y prime 0 equal to 1 that if it's fulfill this condition, means that now it's fulfill these three things. So we can say that y equal to 1 over 2 sine 2x is a solution for differential equation. So class, it comes to the end of week 1 video. Thank you for your attention. See you in week 2 video.